Now I will demonstrate about the classical assumption tests, which are the normality, heteroscedasticity, multicollinearity, and the autocorrelation test. So I will open a set of data. Okay, so this data is to test the cash turnover ratio and the receivable turnover ratio towards the return on asset. Yeah, so the independent variables are cash turnover ratio and receivable turnover ratio. Meanwhile, the dependent variable is the return on asset. So in order to test the classical assumption method or test, we need to find the regression. Okay, so by clicking the analyze and then regression and then linear, so put the dependent variable on the dependent box and then the independent variables into the independent box, and then click the statistics, click the collinearity, and then Durbin-Watson, and then click plots, and the z-pred is on y and this SRE-SID is on x, and then we save unstandardized residuals, then continue, then click OK. Okay, so before we go on to the result, first of all, we want to test the normality of this regression. So we have the residuals that we have saved. In order to test the normality, I use the Kolmogorov-Smirnov. Okay, so you will click analyze and then non-parametric tests and then legacy dialogues, one sample KS. So you put your unstandardized residual, move it to the right side of the box, okay, and then click OK. So as you can see here, the p-value, okay, the very below one, is 0.2. In order to pass the normality test using Kolmogorov-Smirnov, is that the p-value must be more than 0.05. Okay, so now it is 0.2. It means that it is already past the normality. Okay, so the normality test is already passed. And then the second test is the heteroscedasticity, okay, in which you can use the scatterplot. Okay, this is the scatterplot that we have generate just now from the regression. Okay, in the plot side. Yeah, in the plot side, to pass the scatter plot, the dots must be spread randomly. Okay, if you find that your result is of the dot is accumulated in one place, so that it is become black in one section, it means that you don't pass the heteroscedasticity. But this one, as you can see, it is clearly spread randomly, so it means that the heteroscedasticity test is passed already. Another test that you can use to test your heteroscedasticity is the Glejser test. So in order to perform the Glejser test, you need to transform your residuals into absolute amount. So the target variable, you just click write ABS, RES, and then the numeric expression is ABS, open bracket, put your residuals, close bracket, then OK. So here there is your absolute residuals, and then you will analyze and then regression, linear. Okay, you change your dependent into your absolute residuals. So you untick all of what you have ticked just now. Okay, and then the plots, just remove it and then untick the residuals. Then okay. So in the Glejser test, what you need to see is only this one, the p-value in the coefficients table. To pass the Glejser test, the p-value must be more than 0.05. Okay, so as we can see here, the cash turnover ratio and the receivables turnover ratio, the p-value is more than 0.05. So it means the heteroscedasticity test is passed. So up to you which one that you want to use, as long as you pass the test. And then we go back to our original regression and we go on to the multicollinearity test, which we can find it here. Okay, so for collinearity, there are two things that we need to see, which are the tolerance and VIF. To pass the tolerance, the amount must be more than 0.1. Okay, so as we can see here, it is 0.797 for each of the variable. So pass the tolerance test, and then the VIF must be less than 10. So as we can see here, it is 1.254. So already passed the multicollinearity test. The last one is about autocorrelation, in which we use the Durbin-Watson. Okay, so the Durbin-Watson here is 2.265. Okay, we need the find the du. Yeah, to pass the Durbin-Watson test, the Durbin-Watson amount must be between the du and 4 minus du. Okay, so we need the Durbin-Watson table. Okay, just find it in the internet. So this is the table. First of all, we need to determine the k. So the k is the independent variable. Yeah, so we have two independent variable, means that k is 2. And then the n is the total data. So the total data is 10. Okay, so we find the intersection and find the du. So the du here is 1.6413. Okay, and then we need to find how much is 4 minus du. Okay, so 4 minus 1.6413, okay, it will equal to 2.3587. And we see our Durbin-Watson once again. Okay, it is 2.265. So it is more than the du and less than 4 minus du. So it means we pass the autocorrelation test. Another test is you can do the run test, yeah, for the autocorrelation, which is you can use analyze, non-parametric test, and then runs. So you just put your unstandardized residuals, and then you can see the p-value must be more than 0.05, and this is 0.737. So it means it also passed the autocorrelation. Which one that you want to use, it is up to you, as long as you pass the test.